In this video, we're gonna learn the completing square method. There are two types of problems. The first type, rewrite using a complete square. So it says rewrite using a complete square. So we're gonna study problems like this. For example, when you have x squared minus 6x plus 5, you can rewrite this with a complete square. So you can see on the right side, there's a complete square. And they are exactly the same, but you rewrite it with the complete square. That's the first type. So rewrite using complete square. So then the second type, uh, solve by completing a square method. That's a different type of problem. So it says that solve by completing square method. So that means we're going to do problems like this. So let's say we have x squared minus 6x plus 5 equals 0. Now this is an equation. And then you can rewrite it like this. You can write this one as x minus 3 squared equal 4. And then what we do is we can take the square root of both sides. And you can see in the two different problems, we write the complete square in two different ways. The first one we write as x minus 3 squared minus 4. In the second one, we write x squared minus 3 squared, but we're going to have the x on the other side. So that's the different argument we're going to make. So let's see how it's going to work now. So let's talk about the method. So the method can start with a familiar identity, and we know that the a plus b squared, so which is a plus b times a plus b. So we can distribute this. When you distribute, you're gonna get so you multiply with a, so you're gonna get a squared, and then so we're gonna multiply a and b, and then b and a. So that means you're gonna get uh, ab term twice, so you're gonna get twice ab, and then finally we're gonna multiply these two terms, so you're gonna get b squared. So that is the famous identity for the sum squared. Now what we can do, we can look at a special situation. We can see instead of a, I'm going to use x. So let's say x, and instead of b, let's say b over 2. Okay, we do that for a reason. And when you square, according to the identity that we have, this should be what? So how we remember the identity? You can see the identity we have. The first one is squared, twice the product. That's what we normally call it. 2 times the product, and then the last one is squared. So that is the easy way to remember. The first one is squared, 2 times the product, and the last one is squared. So we're going to use the same argument here. So that means you're going to get x squared, that's the first term squared, and twice the product. So 2 times the product. You have x, and the other term is b over 2. And then the last one is squared, which is b over 2 squared. Sometimes we have to simplify the last term. Sometimes we don't have to simplify. So let's see what's going to happen when you do problems. But what is interesting is when you simplify in the middle term, you can see the 2 and 2 get cancelled. So you simply end up getting x squared plus xb. So x times b, and then the last one we have b over 2 squared. I'm going to leave it like that. So so that's exactly the result what we need, but what we normally do is we can write backward because we try to go backward. So we can write this one like this. So we can write this one as x squared. So we just write backward, and then also I'm going to write the b first, bx. That's also for a reason. And then we have b over 2 squared, and you can see that b over 2, b is the coefficient of x. So what we do is we can take the half of that and squared. So that is the special term. And this is equals to, according to this, so what I do is I just write backward. That's the only thing I'm doing. So this one going to be x plus b over 2. It's always the case. So b can be positive or negative or even 0. So it doesn't matter. So that is the formula. So this is what we use as the formula for completing square. That's completing square method, but we write it backward. So this is the completing square method. Completing square. Completing square method. So we write backward. We start with the expression and then we write as a complete square. And then this is true for any b. It can be b can be positive, negative, or even 0. So what we did was, so this is what we need to remember. So we add. So what we did was we add the half of. We add the half of the coefficient of x, or what we can say half of b squared. So that's what we add. So this is simply b over 2, that's a half of b, and then we can square that. So that is the special term that we need to add every time to make it a complete square. So that's the only theory part. So let's see, now let's look at the two cases, the type 1 and type 2. So let's look at the first one. So in type 1, what we do is we're going to rewrite using a complete square. So you're going to rewrite using a complete square. So this has these 5 steps. So step 1, you're going to rewrite in standard form. So that's, you have to be careful because sometimes it's not in the standard form. So you have to write them in the standard form. Standard form means you can write this one as, if you have a number, so like a, so I'm going to say a x squared plus bx plus c. So that is the standard form. You have to write it in this form. If it is not in the right order, you have to rearrange the term and write it like that. So that's what we call standard form. And then we're going to find b over 2 squared, and then we're going to add. So we can talk about what if a is not equal to 1 later. So when you do problems. So we find b over 2 squared, and then we're going to add and subtract. So that's very important. We're going to add and subtract, because this step would be different in the other case. So add and subtract b over 2 squared, and then collect 3 terms, x squared, bx, and b over 2, and we're going to collect all 3 terms, and we're going to rewrite this as a complete square, because this is exactly equal to x plus b over 2 squared. So we're going to rewrite those 3 terms like this. So you need all 3 terms to that. And then what we can do, we're going to simplify the other numbers. After we collect these 3 terms, you have 2 more numbers. You're going to simplify that and get a final number. So those are the steps to do a complete square problem. So let's look at a few examples now. So let's look at the first one. So like say we have x squared plus 6x plus 13. So what we can do first, we can identify the coefficient of x, so which is plus 6 in this case. So what we can do, we can take the half of that and square. So when you do that, you're going to see that half of this is 3, so squared means 9. So the 9 is the special number. So what we're going to do, we're going to add and subtract 9. So we can write this one as x squared plus 6x. And then we add and subtract 9. You add 9 and subtract 9. Why we do that? And then plus 13. Why we do that? And you can see that because you need to make sure they are equal. So when you add subtract, it is like 0. So this is simply like 0. So you add like a 0. You can always add a 0. So that's the whole argument. So it's like it's a 0, but it's special 0. Now what we can do, we're gonna collect the special terms here. So the special terms would be these first 3 terms, and then you can see that you're gonna simplify these 3 terms. You can rewrite these 3 terms as a complete square. So what is it? It is x plus half b squared. So x and then half b. So the b is this one. So we can take the half of that. That means plus 3, and then squared. So that's coming from the formula, because that what is in the parenthesis equals to x plus 3 squared. And then what we're going to do, we're going to simplify the rest of the terms. So we're going to simplify this side. So when you simplify that, and you can see that you're going to get 4. So this is going to go plus 4. So that's how you write this as using a complete square. So it's very simple, and then these are the steps that we use. So let's look at another one. So let's say we have x squared minus 8x minus 5. So we're gonna follow the same steps, and again we're gonna see what is the special number. So I'm gonna put like a line there just to so that they are different. So again, so you can see this is the coefficient of x, so we're going to half of that. So take the half of that and square. And since we square this, the negative sign does not really matter. You can even ignore the negative sign because we square is always positive. So that means when you take the half, you can either say it's 4 or negative 4. So negative 4 is squared in 16. So 16 is the special number that we need to add and subtract. So that means we can write this one as x squared minus 8x. And then what we do, we add 16 and then we subtract 16 and then we still have the negative 5 left. So we can collect these three terms and we can write those three terms as a complete square, which is x. Half of the coefficient always goes there. So half of the coefficient goes there. So that means if you take half, you get negative 4 this time and then squared. That's the formula says. And then we're gonna simplify this side. So when you simplify, so you're gonna get negative 21. So it is negative 21. So that's what you get for the second problem. So as the next one, we can look at this one. So let's say we have x squared negative 3x plus 9/4. So again, let's try to find the special number. So take the half of the coefficient and squared. So I'm going to draw a line here. So it is negative 3 over 2 squared. And when you square, you're going to get from the top, you're going to get 9. From the bottom, you're going to get 4. And you can see that exactly match the term here. That means you don't have to do anything here because we already have it. So that means this is simply going to be x, half of the coefficient of x, which is negative 3/2, and then everything squared. So and then you don't have a constant term in this time because we already have the 9/4 here. Good. So that's already a complete square. So let's look at a few more examples. As the next problem, we have 2x squared plus 8x plus 3. So this problem is different from all the previous problems. You can see that there's a which is not equal to 1 this time. So if you see a number which is not equal to 1 as the coefficient of x squared, what we can do, we're going to factor that out from the first two terms, just from the first two terms. So we're going to factor out 2 from the first two terms. So this is what we do now. So we factor out 2. So when you factor out 2, that means you divide by 2. So you're going to get x squared. When you divide 8 by 2, you're going to get 4x. So that's what happened from the first two terms, and we're going to leave a space, and then we write 3 separately. Now we're going to find the special term. So the special term is again the coefficient of x, the half of the coefficient of x squared. So that means it is 4 divided by 2 squared. You can see that which is exactly 4. So that is the number we can add here. But when you add a 4, it is not just 4. You can see that 4 you multiply with 2 in front. So that means it is 2 times 4, which is actually 8. You actually add 8, not just 2, not just 4, because you have to multiply with 2. So it's 2 times 4 is 8. So that means to cancel the effect, you're going to subtract 8 this time, not 4, 8, because you multiply by 2, because that's the term you add here. Now the rest is very similar to what we did earlier. So you can see that this is 2, and then we know that the three terms that you can write as the complete square. So it's going to be x, and the half of the coefficient of 4, which is negative, which is 2. To the half of that, and put it there, and then square, and then we can simplify the two numbers over here. So when you simplify the two numbers, you're going to get negative 5. So that's how you're going to rewrite as a complete square this problem. So only thing that that is different from previous is you had a 2, so you factor out 2 only from the first two terms. So let's look at another problem. How about we have negative 3t squared, it doesn't matter what variable you have, and then plus 5 plus 6t. You can see that there are a few problems here. So one is there's a coefficient of t square which is not equal to 1, and also you can see the special main problem is the terms are not in the right order. So we're going to rearrange them and write in the standard form first. So that means you're going to see the t squared term first and the t term next, and then the constant term. So we put them in the standard form first. And then you can see this problem is very similar to the previous problem. So what we can do, we're going to factor out the coefficient of t squared. So that means we're going to pull out -3. So what means you're going to divide the first two terms by -3. So we're going to get t squared here. And from the other terms, what's going on is you divide 6 by -3. So that means when you do that, you will end up getting -2. So you're going to get -2 t, and then you leave a space and write 5 outside, and we're going to find the special term here. So you can see the coefficient is -2, so we take the half of it and squared. So it is -2 half of it and squared, so which is simply 1. So you add a 1, but when you add a 1, and you can see it is not really 1, it is 1 times -3, so that means it is -3. So you add a -3 to cancel that, you add a +3. So now everything looks good. So we're going to have -3. So this is the complete square. The next three terms is the complete square. It is t, and the half of the coefficient, which is -1 and squared. So this is automatic, and then 5 plus 3. So you have 8. So that is the complete square for this problem. And you can see that it's not that difficult. So let's do two more little complicated problems now. So how about -1/2 x squared plus 3x -7. So you can see this again, you have a coefficient in front. So we're going to pull that out. So when you do that, you're going to get x squared. And how to do the next term? So what you have to do next is you have to divide 3 by -1/2. Let's see how the algebra works. And if you are not familiar with how it works, and you can see my other video about simplifying fractions. So we talk about like how to do these kind of problems quickly. So it is so what you're going to do is you're going to divide 3 by -1/2. That's what you want to do. So negative sign automatically comes here, and we know that the division, dividing by a fraction means multiplying by the reciprocal. So that means you end up getting -6. So that means so the next term is going to be -6x, and then again as before, we leave the constant term outside, and then what we need to do is now find the special term. So you can see the special term is, it is in this case it is -6 divided by 2 squared. So you can see which is 9. So you add a 9. And when you add a 9, and you, as we discussed before, it's not 9, it is 9 times 1/2. So that's 9/2, but it's a -9/2. So since this is -9/2, you add a +9/2. Good, to cancel that. Okay, now we're going to simplify this. So you can see it's -1/2. Now this is automatically the complete square, which is x, and the half of the coefficient, which is -3. Squared, and then we're going to simplify the fraction. How to simplify the fraction? So when you have fractions like that, the easy way is you're going to multiply these two numbers and then add these two next. So that means when you multiply, you're going to get -14, and then when you add, you get -5. So it is -5 over 2. So -5 divided by 2. So that is the completing square for that problem. And you can see it's not that difficult, but still, you know, there are a few steps that we need to be careful how to do. Okay, let's do one last one from this type. How about we have this? So 4 minus 5x minus 2/3 x squared. And when you look at this problem, there are several troubles here. So you can see that the first thing is they are not in the order. So we're gonna write them in the order first. So we have negative 2/3 x squared, and then negative 5x, and then plus 4. So we're gonna bring it to the standard form, and then as before, we're gonna pull out the leading coefficient. That's what we normally call the leading coefficient. So when you pull out that, you get x squared, and again we have a similar fraction division here. So we have a negative 5, and you're going to divide that one by negative 2/3. So again, negative negative get cancelled, so it is 5 times. You flip over the fraction, so you get 15/2. So this simplifies to 15/2. So that's exactly what goes here. So it is 15 divided by 2x, and then again plus 4. So we need to find the special term. So a special term is the half of that. So half of this. So half of this means so when you divide by 2 means it's a multiply by 1/2. So you can think of like that. So it is 15/4. That's what you get, but you have to square that. So that's what we need to add here. So that means we can add the square of that. So which is, let me erase this one. So which is 15/4 squared. So that is the term you can add. And then when you add again as before, you can see that you are not just adding that, you are adding the multiple of these two. Since it is negative, we add the positive of that. So that means it's going to be positive 2/3 times 15/4 squared. So let's see how we can simplify this part. So first we can rewrite this one as negative 2/3. So this part is done. This is x, and the half of the coefficient, which is 15/4. Now we go to that another half, so it's going to be 15/4 whole thing squared. Now only thing left is we need to simplify that. So let's simplify the fractions. So this is what we can do. So I'm gonna simplify it over here. So we have 2/3 and 15 squared, so it's 15 times 15, and then 4 squared is 16. So then what happen is you can cancel one of them, so you're going to get 8, and you're going to cancel 1 3, so you're going to get 5. So and then we have 5 times 15/8, so it's going to be so plus 4 plus 5 times 15 means 75/8. Now we can use a similar argument that we did before. You're going to multiply these two and add that. So multiply and add. That's a shortcut. So when you do that, you're going to get 4 times 8 means 32, and when you add 75, so 107. So that means you finally end up getting negative 2/3 x plus 15/4 whole thing squared plus you're going to get 107/8. So that is the final number you get. Yeah, that's a little complicated, but that's how you do it. Okay, that's about that. Let's look at the next type, the how to simplify, how to solve using the complete square method. So let's talk about theory first. So type 2 is solved by completing square method. Now this is a this has like some different steps compared to the previous step. So let's look at the steps now. So we have these steps. So the first one is rewrite in the standard form. So if they are not in the right order, so rearrange the terms and write in the standard form. And then the constant, move the constant to the right hand side. Move the constant to the right hand side. When you do that, and you know that it's going to change the sign. Okay, change sign. Change the sign of the constant term. Because when you move to the other side. And then add b/2 squared. That's a special term. That is the coefficient of the x term. And you take the half of it and square. But now you can add that to both sides. That's not what we did in the previous case. Previous case you add subtract. Now what we can do, we can add it to both sides. So that's why it is different from the previous step. And then rewrite the left hand side as a complete square. It is always going to be x plus half of the coefficient of x squared, the whole thing squared, that's a complete square. And then you're going to simplify the right hand side, and then you have to take the square root, because the complete square you get the square root of both sides. But when you do that, you're going to get two solutions, because when you take the square root, because it's square, you get two answers with plus or minus. So you're going to get the plus or minus to 1, and then finally you're going to solve for x. So those are the steps when you want to solve a problem using the complete square method. So let's see a few examples to see how it works. Solve by the completing square method. So let's look at the first example. So we have x squared plus 4x plus 3 equals 0. So you can see the major difference right now is we have an equal sign and some number on the other side. So that is the major difference between the previous type and this type. So we're going to follow the new argument. So what's the new argument? We're going to move, and you can see that this is already in the standard form. So we're going to move the constant term to the other side. So that means we can, and then we leave the rest here. So that means the first step is we leave x squared plus 4x on this side, and we're going to move the constant of the other side. That means we're going to switch the sign. So plus 3 become minus 3, because what we do is we subtract 3 from both sides. Okay, now we're going to find the special term. Special term is always half of the coefficient squared. So it is 4 divided by 2 squared. You can see which is 4. So what we do, now we're going to add 4 to both sides. So we're going to add 4 to the left side and add 4 to the right side. So that is the new step. You can see this is different from the previous step. Right after we do that, the left hand side is a complete square. It is x. It is the half of the coefficient, so which is plus 2, and the whole thing squared on this side. The other side you simplify. When you simplify, you get 1. Now what we do is we can take the square root. So taking square root, I'm going to write this one because this is the first example. Taking square roots, we have on this side x plus 2 equal, when you take the square root, actually you can write it, I'm going to write it like that. Take the square root, and you take the square root on this side. So what happened, you add a plus or minus to one side. So that's what happened. So that means this simplifies, because square root of a square, that means you get x plus 2 here, the other side plus or minus 1, square root 1, which is 1. So what we can do now is we can consider two cases. So we can consider one case with the plus sign. So that means x plus 2 equal 1, or x plus 2 equal negative 1. And then we subtract 2 from both sides. So you can write this one as x equal negative 1 when you subtract 2 from both sides, or x equal, if you subtract negative 2, you get negative 3. And those are the two solutions. And this is how you use the completing square method to solve the problem. So let's look at another one. We have x squared minus 8x minus 5 equals 0. And you can see it is in the standard form. So what we do is we're going to move the number to the other side. So we're going to add 5 to both sides first. So that means we're going to get x squared minus 8x. So we're going to move, so it's going to be positive 5. So when you change, you just change the sign. So that's the easy way to remember that. If you change the term, just change the sign. Now we're going to find the special term, that is the half of the coefficient squared, so which is negative 8 over 2 squared. And again, we can ignore negative sign because it's square. So you're going to get 4 over 2 squared, which is 16. So we're going to add 16 to both sides, to this side and to the other side. So when you do that, this is automatically a complete square, is x half of the coefficient, which is negative 4 squared. This one is 21. Now we take the square root of both sides. When you take the square root, you're going to get x minus 4 equal plus or minus square root 21. And you can see that you cannot write 21 using a complete square, like perfect squares. The perfect squares are 1, 4, 9, 16, 25, 36, 49, 81, and 100. So first you check whether you can write this using any of these, but you can see that 21 you can write it using any of them. That means you don't simplify like that. So the only thing that we can do, we can add 4 to both sides. That's the only thing we can do. We can add 4 to both sides. So then you can write this one as x equal 4 plus or minus square root 21. So that is the solution we're going to get for this problem. So let's look at another one in a slightly different form. So let's say we have t squared minus 5 equal 7t. You can see that this is not in the standard form. So the first thing we do is we're going to move the terms and write in the standard form, and then also move the constant term to the right hand side. So that means we can rewrite like this. So we're going to say t squared. We're going to move the 70 to this side. That means it's going to be negative 70. And then we're going to move the constant to the other side, becoming positive 5. Just change the sign. That's the easy way to remember. Now we're going to find the special term. So the special term is half of the coefficient of t squared, so which is negative 7 over 2 squared. So it is square of the top is 49, square of the bottom is 4. So that's the special number that we need to add to both sides. So it is plus 49 over 4 and then plus 49 over 4. It's always plus because you add the term. So now this left hand side is automatically t, half of the coefficient of that means negative 7 over 2. That's the term goes here, squared. The other side you need to simplify, and then we can use shortcut. So we're going to multiply and add. So multiply and add. So we're going to get 20 plus 49 is 69 over 4. And then take the square root. So when you take the square root, it's going to be t minus 7/2 plus or minus. We add plus or minus to only one side. And then take the square root, 69 over 4. And the thing is that you know that you cannot write 69 using a complete square. So that means you're going to leave it like that. So I mean, only thing that we can do is we can write 69 square root divided by 2, because you can take the square root of the bottom one. Now we can add 7/2 to both sides. So we know that t equals 7/2. We're going to move to the other side, plus or minus 69 square root over 2. So the only thing that you can do is I mean, this is perfectly fine. You can also take 1/2 out and write this one as 7 plus or minus 69 square root, because you might see this as the answer, because 1/2 is common, you can pull it out. So that's how you simplify a problem like that. So let's do a few more examples. Let's say we have negative 3t squared plus 12t plus 4. So this question is different because we have a leading coefficient which is not equal to 1. So what we're going to do, we are not going to divide by that. When you divide by that, it's going to introduce some fractions, but we're going to leave the fractions to the end. So what we're going to do is we're going to do the same way as we did before. We're going to factor out that and then move the constant over the other side. So that means what we're going to do is we're going to leave 3t squared and 12t on this side and move the constant to the other side. So to get first, and then what we can do is we're going to factor out the leading coefficient, just to factor out that. So it is negative 3 t squared, and then because you're taking a factor out means you divide by that, so that means you do 12 over negative 3. That means you're going to get negative 4t, because you can see that so it is 12 over negative 3. So and then you can see that when you multiply negative 3 and negative 4, you get 12. So that's perfect, right? And then again we need to find what is the special term. So special term is you can take the half of this and squared. So we have done that several times. So it is half of this squared, so which is 4. So you can add a 4 to this side, but when you add a 4, you are not really adding a 4. You're adding the product. You're adding negative 3 times 4. So you're adding negative 12 actually. So you add a negative 12, so that means you can add a negative 12 to the other side as well. So it is a negative 12 because you add negative 3 times 4, it's negative 12. So you add a negative 12 to both sides, because since you're adding to the both sides, it has to be the exact same number that you're adding. Okay, now after that, it's very simple. Now it's a 3, and this is a complete square, which is 3, half of the coefficient, which is negative 2 squared on this side. The other side is negative 4, 12 means negative 16. And then you can see both are negative. Okay, now what we can do is, after we do that, then we're going to divide by this negative 3. So this is when we do it. So when you divide by negative 3, so you can see that it's negative 2 squared equal negative 16 divided by negative 3. Negative negative cancel, you get 16 divided by 3. Okay, now we take the square root. So once you take the square root, you're going to get plus or minus 16 over 3 square root, which is equal to plus or minus square root of 16 is 4, and the square root of the bottom is square root 3. So you can leave it like that. Now we can add 2 to both sides. So when you add 2 to both sides, it's going to be 2 plus or minus 4 over square root 3. So that is the solution, and we can leave it like that. If you want, you can do the rationalize the denominator, but that's we normally did like early days. The reason is now we use computers, so this is not a difficult task anymore. Okay, so let's do one more. So we have let's say x squared plus 21 minus 6x equals 0. So you can see that it's not in the right order. So what we can do, we can rearrange. We can write x squared minus 6x and then move the constant of the other side. So it's negative 21. And then we're going to find the special term. So we can take the half of the coefficient. So we just say number because it's organic square. So it is 6 over 2 squared, which is 9. So you add a 9 to this side, add a 9 to the other side. Good. When you do that, this automatically completes squares. X half of the coefficient, which is negative 3, everything is squared. The other side is negative 12. Now we have a square which is equals to a negative number. So this is negative. And then so what we need is we need complex numbers now. So need complex numbers. Otherwise, there are no real solutions for this problem, because how a square can be a negative. So that means we need to work with complex numbers. And if you are not familiar with the complex numbers, and there's a video about basics of complex numbers for algebra and pre-calculus students, and you can look at that. You can see the link in the description. It's about basic, just the basics of complex numbers. So I need complex numbers. In complex numbers, we know that we're going to use the basic fact, the I squared. We can assume that that is negative 1, or in other words, we're going to say I equal negative 1 square root. So that is the notations that we can use here. So let's see how the rest of the work. So we're going to say a square root. So taking square root, so we do the same thing. So taking square root, taking square roots. So this side is x minus 3, the other side is plus or minus as before, square root of negative 12. So that is the different one. But how we do this? So what we do is we can replace the negative sign by I squared. So we can write this one as 12 I squared. So that is the major difference step, because I squared equal negative 1. So we write it like that. Now we can take the square root. But how to do that? We know that the 12 is 4 times 3. That means square root 12 is take the square root of each term, square root of 4, which is 2, square root of 3, which is square root 3. So we can write it like that. That's much better. So that means your final answer, you can write it like this, so plus or minus. Square root of 12, you can write as 2 square root 3. Square root of I squared, you can write as, that's just I. When you take the square root, it's I. Because plus or minus is already there, so you don't need another one. Okay, that's how we do it. And then we can add 3 to both sides. We can write the final answer as x equal, adding 3 plus or minus 2 square root 3i. So that is the, but that's complex. So this is a complex solution. Complex solution. There's no any big difference here. Only thing is you have to take a square root of a negative term, and this is how we do it. Okay, let's just do one last problem. So let's say we have this one. So we have negative 1/2 t squared equal 3d plus 4, and there are a few problems here. So one thing is we have a fraction, and then also this is not in the standard form. So let's write them in the standard form first. So it is 1/2 t squared, and I'm going to move the 3t term to this side, leave a space, and leave the constant on the other side because we had to do that anyway. So we leave it there. So next, what we're trying to do is, this step is completely different from the type 1 method. Type 1 method, you have to leave the constant term, a leading coefficient. But in this time, actually, we can remove this leading term. We can divide by negative 1/2 because we don't need that anymore. So that is completely different from the previous, the type 1 technique. So this step is different. So to do that, the simplest thing that we can do is to remove the negative sign. You can multiply by negative sign. And to remove the half, you can multiply by 2. So basically what we do, we multiply by negative 2. That's how I do. So multiply by negative 2. Okay, negative because of negative sign, 2 because of 1/2. Okay, so when you do that, and you can see that this simply becomes t squared, and you multiply negative 2, it becomes negative, this is going to become positive 6t. The other side is going to be negative 8. Now this is a very simple problem after we do that, and you can see they're going to get the half of this coefficient squared. So it is, we have done this several times. I'm still writing it for the completeness. So it's 9. So we add a 9 to both sides, and then this is simply t plus 3 squared equal, on the other side is 1, and take the square root. So when you take the square root, you're going to get plus or minus square root 1, which is plus or minus 1. Consider the two cases, t plus 3 equal 1 or t plus 3 equal negative 1. And subtracting 3, you're going to get negative 2 or t equal negative 4 as the solution. So you can see that's not that bad, and this is how we're going to simplify this. So you can, I'm going to post some practice problems in a separate video, and you can try them just to master the technique. So this is how we solve the problem. Thank you. Now you can try the following problems as practice problems, and you can find the answers in the description.